Good afternoon. The thesis of this project and end goal as a whole was to create a VR controller that is simple to understand, low cost, and is compatible with VR software on smartphones. Our thesis was based on data that we learned from Assessment 1. This being that 80% of VR users use it for entertainment purposes. Because of this, the technology hasn't yet reached its full potential. 43% of manufacturing companies say that VR will become mainstream in the organization within the next 3 years. And so it will become vital for a company in this industry to embrace this technology. It will be important for employees to become accustomed to these technologies, and to account for the high cost that usually comes with VR, the easiest and best solution would be to use smartphone VR. This is because all modern smartphones have the capability for VR, as headsets already exist for them, and so practically everyone has access to VR in their pockets. To ensure that employees get the most of VR, it is vital that they have controllers. 2 degrees of freedom VR controllers that are easy to understand and are relatively low cost are ideal because most people get confused with controllers that have complicated button layouts and that can ruin the experience. Creating easy to understand controls can bypass this issue to ensure the best possible work for users. Before we came up with the designs, we first looked at the leading edge technology in VR, these being the Valve knuckles, seen on the left, capable of tracking each individual finger motion for the most immersive controls possible, and the Tesla suit seen on the right, having full body haptic feedback and motion capture capabilities and their own gloves that can do the same thing and can even be programmed to simulate touch. Though both of these are very expensive, and in the case of the Tesla suits, not available for commercial purchase. After brainstorming several ideas, we decided on 3 concepts. We made dirty, low-fidelity prototypes made of foam for each concept for testing. We ended up going with concept 1 as the best suited the goals we had set. There were issues with the original concept, so we redesigned it and got to work making a clean, low-fidelity prototype and a 3D model for augmented reality. The 3D model for augmented reality was made as a sort of guide to what the physical prototype should look like, as well as helping in figuring out the general size of the model that would fit the user's hand, as it did not have area for the internal components, including the Arduino Nano, because it was just meant as a general guide for the following prototype, as you can see in the bottom left. The clean low-fidelity prototype was made of modeling clay. We created it to test the size, grip, and form of the controller to see what improvements should be made before we got to the buttons and other components. We had 4 users test the prototype to get their feedback. The positives of the prototype were found to be the shape and form of the model, whilst the negatives were the size and grip, as the user said that their fingers were being squished together and it was hard to have a strong grip on the controller because of this. So for the next prototype, we focused on improving the size. The second prototype was a working low-fidelity prototype made out of cardboard and electrical tape-padded grip. It was originally intended to be a high-quality prototype, but we underestimated the difficulty of making smooth, curved models with cardboard. We focused not only on size and grip, but also on how the Arduino Nano would be in the control of basic trigger functions. The Nano in particular didn't work as the way it was meant, as it would turn around inside when the user was twisting the controller, stopping the controller from twisting in unity. The common positives of this prototype were that it was easy to hold onto, and the side was good as it felt comfortable in the hand. The negatives were that the Unity functionality didn't work as intended and it felt flimsy. Some felt that the trigger was good, and one thought that the trigger did not work as the trigger should. For the next prototype, we focused on improving the durability, making the trigger function normal, and fixing the Arduino issues. This prototype was a final working prototype made out of MDF board and using bung salvage from an old PS2 controller and cardboard for the trigger. It was meant to communicate the overall finalized concept. It was also meant to test the general button layout from the initial prototype from Assessment 2. Holes were drilled into the model so that buttons could be pushed into place, as these buttons got their pushback from rubber bosses that they sat on top of, as you can see on the left. The trigger was a combination of a button and cardboard. The button was so that the pushback was given, and the cardboard was to make it feel more like a trigger, as you can see on the right. By this point, we had decided to drop the analog stick from the original concept, as we felt it was not needed to meet our goals or for the intended use. The positives highlighted were that it felt really good and comfortable to hold. The trigger felt good and felt satisfying to use. The buttons were in the exact right spot as the user's fingers was on it by default when they held the controller, and that the weight was good as it wasn't too heavy to the point where it would cause strain, and it wasn't too light either. The negatives highlighted were that, again, the Unity did not work as it should have. The trigger being a single bit of cardboard made the whole thing feel cheap. The trigger was angled too high, it felt too small and too straight. The button on the side felt too small, and for one user, they found it better to hold the controller with the index finger on the trigger and thumb on the side button, as seen in the bottom left, as compared to the way as when using it as intended, they felt it was too confusing. The improvements suggested for the next prototype, if it were to be made, were to make the form more curved as it might make it easier to hold the control as intended, to make the trigger angle down at more of a 90-degree angle, making the sidebar longer and shape more similar to a finger, making the end of the controller go just past the user's palm and to create a higher quality trigger. We did, however, attempt to create a 3D model as a representation of what the next prototype would have been, as you can see. Although our skills in SolidWorks were not satisfactory enough, as you can see. If the prototyping process were to continue past this assessment, then the next stage would have been 3D printing, so we don't have to use an augmented reality model, but rather make the physical model. This next model would have been primarily focused on improving quality, reworking the button layout, improving the form, and improving the nanoplacement, as you can see, especially with the Arduino sitting inside the chip of the controller. In conclusion, the end goal of creating a low-cost, easy-to-understand 3 degrees of freedom controller has not been achieved by the prototyping, as you can see by the taxonomy. While the prototypes are making progress towards this goal, they still need to be improved upon. Working from home has put limitations on us, as we can only make do with what we have and can't use 3D printers or laser cutters or anything like that, which would have not only allowed us to make higher quality prototypes, but also make them faster, allowing us to make slight changes and tweaks here and there from iteration to iteration. As you can see by the storyboard of the prototyping process, it is a long process just to make one prototype. Thank you.